Hello everyone, and welcome to Section 1.2, Statistical and Critical Thinking. The key concept in this section is to provide an overview of the process involved in conducting a statistical study. There are three major steps that we're going to focus on: preparing, analyzing, and concluding. Okay, let's start with preparing. When we're getting ready as researchers to design a statistical study, the first thing we need to look at is the context. What does the data mean? What is the goal of the study? You need to ask yourself these questions before you even get started. So you have to understand, what are you trying to achieve in this study? What population are you trying to get at? How are you going to go about your study? And these are all the things that are important to consider right from the get-go. Continuing, also part of the preparatory phase, is the source of the data. Something to consider is whether data is objective or biased. Objective means that the source does not have another motive behind how they're answering questions. Objectivity is important in a statistical study, as biased data can skew results. So what is biased data? Bias is where there is some type of motive or reason that is going to lead people to answer questions in a certain way that could impact the results of your study. So an example of this, a lot of times people talk about whether the news or media is objective or biased. So it's important to consider that. It's also important for you as a researcher to consider your own objectivity with relation to your studies, and to be sure to always be trying to reduce bias and maintain objectivity. The other thing to consider is when you're reading someone else's studies. You want to be vigilant and skeptical of studies from sources that may be biased. For example, back in the day when cigarette companies used to donate money to studies to say that cigarette smoking was safe. We all know that nowadays researcher has clearly shown that smoking is not safe, but back in the day, these studies that were actually paid for by cigarette companies showed the contrary. And without people looking at the source of that data, no one questioned whether or not the fact that the cigarette companies were paying for these studies was skewing that data, as we now know it was. So again, it's really important to be vigilant and skeptical and to look at the sources of any kind of data, especially when you're designing your own studies, but also when you're reading other people's studies. The next part of the preparatory phase is to determine your sampling method. One question you have to ask yourself is, does the method that you choose influence the validity of the conclusion? And as we will see, and we'll get into talking about sampling methods in a little bit more depth coming up, but yes, the method can very much influence the validity of the conclusion. So it's important to think through which sampling method is best based on what you are trying to achieve in your study. Some examples of methods. One of those is voluntary response, or also what's also called self-selected. So these are where people are being given the option to participate or not to participate. And oftentimes these samples can be biased because those with a special interest are more likely to participate. An example that I always think of is when I go to, for example, a restaurant, and they have a survey that I can fill out to get $5 off my next purchase the next time I come in. Now, sure, there's going to be people who are going to voluntarily go on there and do the survey so that they can have the coupon. But the other sad reality of it is that a lot of people are going to go on there to complain. And so people who have had a bad experience are probably going to be more likely to participate in a study because they want that feedback about their experience to reach management of the restaurant. So not that it's a problem that they are voluntary responding, but it's important to consider that bias and what that actually will do to your results. And we're going to talk through other methods that are more likely to produce good results than a voluntary response in the coming slides. Moving on to the analyzation phase. Every analysis should have graphs. We are going to learn about graphs in Chapter 2, so hang tight there. But suffice to say that graphs are a great way to display data, and as many of us process information better visually, graphs become a great presentation tool and a great way to summarize the results of your study. In addition to using graphs, we're going to apply statistical methods. So that's really the crux of what we're going to be covering in the coming chapters in this course, is learning the different statistical tools that can be applied to data and what they tell us. An important thing to note is that with technology, good analysis nowadays doesn't really require strong math skills. What it does require, however, is common sense, and that you're paying attention to using the right methods for your data. So in this course, we're going to learn the backbone of all the different statistical methods. We're going to learn a little bit about how to use technology to help us achieve those methods more quickly. But really, we're going to focus on using our common sense and our lifelong experience to help us design studies and apply the correct tools that are going to lead us to great conclusions from our data. Finally, we're going to draw conclusions. And in statistics, what we're really looking for is what's called statistical significance. Statistical significance is achieved in a study when we get a result that is very unlikely to occur by chance. So what do I mean by that? For example, if I were to toss a coin 100 times, and out of those 100 times, 99 of them I got tails. That is not a result that is very likely to occur by chance. We know from our everyday experience and probably from coin flipping ourselves in the past that roughly there's a 50-50 chance of getting heads or tails. And so when you have where 99 out of 100 times, or a 99% of the time you actually achieved tails when you're conducting your experiment, we would conclude that something is going on, that it's unlikely to occur by chance, and that we have reached statistical significance. Now that's just a basic example based on kind of common sense things, but in this course we're going to learn more about statistical significance and how to achieve it. We're also going to use our conclusion to state whether something is practically significant. In the previous slide, we talked about statistical significance, meaning that the numbers tell us that the result is unlikely to occur by chance. But we also need to consider the practical significance. Who the heck cares? That's really what practical significance means. So common sense might suggest that a finding does not make enough of a difference to justify its use or to be practical. For example, in a test of the Atkins weight loss program, 40 people had a mean weight loss, and by mean weight loss I mean an average weight loss of 4.6 pounds after 1 year on the diet. Using formal methods of statistical analysis, researchers were able to conclude that the diet appeared to be effective, in that it was statistically significant. However, although a 4.6 pound weight loss is statistically significant, meaning the numbers say it's significant, using common sense, it may not seem very worthwhile. You're going to spend an entire year on a fairly restrictive diet to lose less than 5 pounds on average. And so many people would say that although the Atkins diet is statistically significant, its practical significance is limited. Some potential pitfalls. So again, we went through preparing, analyzing, and concluding. Now, don't think we're just rushing through these things. They're going to come up again, but just keep them in the back of your mind as we're moving forward throughout the rest of Chapter 1 and into the coming chapters. Some potential pitfalls to consider when doing a statistical study. One of those is misleading conclusions. The biggest and most problematic misleading conclusion is concluding that one variable causes the other variable, when in fact the variables are only correlated or associated together. What does that actually mean? Two variables can seem linked to one another in that there's a relationship between them, but that doesn't always mean that one actually causes the other. For example, two variables that are linked are smoking and pulse rate. That being said, it can't be concluded that one causes the other. Smoking doesn't necessarily cause your pulse rate to change. So based on that correlation, there is a correlation between smoking and pulse rate, but that correlation does not imply causality. This is kind of a tough concept, and people may have seen this concept in other courses, but just, again, file this little piece of information away for yourself. Correlation does not imply causality. We will revisit this when we get into probability in Chapter 4. Another potential pitfall is small samples. Conclusions should not be based on samples that are far too small. So, for example, basing a school suspension rate on a sample of only 3 students. Let's imagine that the school has 2,000 students, and we're only sampling 3 students to base the school suspension rate. What if those 3 students are 3 students who have never been in trouble? Or what if those 3 students are your kids that are constantly in detention? It's just not a big enough sample to actually draw a conclusion. And in statistics, it's important to make sure that your sample size is adequate based on your population size. And we'll learn in the course how to determine that. So don't worry about it for now, but just something to consider as we move forward. Another potential pitfall is loaded questions. What this means is that if survey questions are not worded carefully, the results of a study can be misleading. For example, look at the following 2 sentences. Should the president have the line item veto to eliminate waste? When worded that way, 97% of people said yes. In contrast, when the sentence was structured, should the president have the line item veto or not, only 57% said yes. So in the first sentence, when the line item veto was related to a specific thing as eliminating waste, people said yes. But just when asked in general if the president should have line item veto, people said no. And so it's important that we consider how questions are worded, and a lot of the times in a statistical study, there is quite a bit of thought put into the psychology of how people read questions and how, based on the way that they're worded, how it influences people's decision making. In addition to that, the order of questions can also be important. Questions can be unintentionally loaded by such factors as the order of the items being considered. For example, when asked, would you say traffic contributes more or less to air pollution than industry? So again, traffic contributes more to air pollution than industry. The results were that 45% thought traffic contributed more heavily to air pollution, and only 27% said industry. However, when you worded the question, would you say industry contributes more or less to air pollution than traffic, or the exact opposite, the results flipped. Suddenly, industry, people felt 57% contributed more to air pollution, and traffic was only 24%. So it's important to consider these things as we're designing good statistical studies. Another potential pitfall is non-response. This occurs when someone either refuses to respond to a survey question or is unavailable. People who refuse to talk to pollsters have a view of the world around them that is markedly different than those who will let pollsters into their homes. So it's important to consider who is going to self-select not to participate in your study. Non-response can be a challenge. So for example, say that you're sending out surveys through the mail and that your population is 5,000 people and you're only going to sample 200 out of those 5,000. Well, if 50 of them choose not to respond, you may have missing data, or you may not be people of a different thought process may not be represented in your data. So it's important to consider non-response and how you're going to tackle that within your statistical study. Going along with non-response is missing data. Missing data can have dramatic effects on your results. Sometimes subjects may have to drop out of studies for reasons that are unrelated to the study. For example, people with low incomes are less likely to report their income. So, based on that, the U.S. Census suffers from missing people. People who are homeless or low income tend not to complete the census, and therefore that data is often missing or is underrepresented in the U.S. Census. Another potential pitfall is precise numbers. The takeaway here is that sometimes when a number is very precise, people assume that precision equals accuracy. And a lot of times it's easy to make that mistake, but a precise number can also just be an estimate. So if we say, 66.1578% of people, you may think that that is more reliable than 65% of people. But the reality is that precise numbers should not be the basis for how we're judging accuracy. Accuracy should be based on the study methods themselves. Another potential pitfall is percentages. Misleading or unclear percentages can sometimes be used, and oftentimes they're strategically used by people to try to persuade readers in a particular way. For example, Continental Airlines ran an ad claiming, "We've already improved 100% in the last 6 months with respect to lost baggage." So the question you have to ask yourself is, what does that 100% mean? Does that mean that Continental made no mistakes in the last 6 months? Certainly not. So I don't know the slides here don't give us the precise numbers from this study, but for example, let's say that in the past 30% of baggage was lost or delayed. If they reduced that to 15%, they've actually improved 100% over where they were. But that doesn't mean that they suddenly aren't losing baggage. They're still losing 15% of their baggage. So it's important to really look at the data and not just what a researcher is telling you about their study. And hopefully with what you'll learn in this course, you're going to have a better skill set to be able to do that for the future as you're reading other people's studies, as well as to consider wording how you word things when you're conducting your own studies. Okay, that is the end of section 1.2 on statistical and critical thinking. Join me next for section 1.3.